guys, welcome back to the PowerMation YouTube channel. J.D. Teter, Business Development Manager Motion with PowerMation. Today we're going to be looking at part 3 of the Trio Motion Toolkit, multi-axis motion control via LabVIEW. Again, joining remotely, Eric Schaffer, President of Schaffer Engineering and the developer of the Trio Motion Toolkit. Eric, take it away, sir.
Well, thank you, J.D. And this is Eric Schaffer from Schaffer Engineering. Joining me is J.D. Teter. And we're going to talk about the Trio Motion Toolkit for LabVIEW, specifically multi-axis motion. So today we're going to talk about future option of motion using Trio. The two options we will talk about today are using the ActiveX functions from Trio and the Trio basic functions. We'll discuss the Trio Motion Toolkit and give demonstrations of multiple examples running multi-axis and then talk about where to find the toolkit. So if it's a future option with Trio, is with Trio Motion Controllers. They are a product of Trio Motion Technology, who has been providing controller hardware since the 1980s. This hardware is supported by PowerMation. The LabVIEW motion is PC-based motion with LabVIEW using the ActiveX library from Trio. Again, we'll be demonstrating these ActiveX functions using the Trio PC library ActiveX library. This is limited to the functions available in the library, but we can also use any of the Trio basic functions in LabVIEW. And to give an example of what these functions are, we're going to take a look at the Trio software reference manual. As you can see, this manual has over 1,300 pages of functions available from the Trio motion, any of which can be run from the toolkit. This is a list of commands available from Trio. And one of them is very interesting, I'm going to talk about, is the frame function. Trio provides a frame function which defines different robotic functions of multi-axis that the user can make advantage of or take advantage of. You need to just define what the linkage looks like and then where your endpoints are, and all the calculations are done on the Trio controller. So the Trio Motion Toolkit has been developed with NI and is approved and available from the LabVIEW Tools network. It is installed using the VI Package Manager. So to find the toolkit or how to use it, let's first go to LabVIEW and on the palette we then go down to Instrument I/O, Instrument Drivers, and from there we can open up the Trio Motion Toolkit. This includes examples and all of the functions, plus a VI tree, as is available in most toolkits. The VI tree will demonstrate to you or include all of the functions plus all of the examples. The examples are inclusive of all functions. So we're going to start out showing the Jog Demo. The Jog Demo here is a 2-axis jogging, and the first thing it does is we set up which the host is, which is the IP address of the Trio controller. We then set up the different parameters for the axes, such as what kind it is. This is a stepper, what its units are, speed. This is 25 millimeters per second, and accelerations. In addition, we can set up the limits, hardware limits, where to locate them on the hardware. So let's demonstrate a jog function here. And we'll show on axis 0, we can jog forward and jog reverse. Similarly, we have set up a second axis, axis 1. Again, we can jog forward and jog reverse there.
That's great, Eric. So you're jogging each axis independently there. What else can you do with each axis?
Well, we can set up any of the parameters on the axis. They're available to us through this pull down. Right now we're looking at speed. So let's say, for example, I wanted to change the speed of the axis. Instead of 25 millimeters a second, let's try 50 millimeters a second. Let's see what happens. The other thing we can do is we can read all the parameters. The one I like to look at most is M position, because that's the absolute position of the axis.
And when you say the parameters, Eric, these are the keywords within Trio basic programming, right?
That is right. These are the different parameters on the axis that Trio uses.
So we've seen jogging and we've seen you move them independently, and we've talked about multi-axis control. Can you give us an example of some multi-axis control using your new toolkit?
I can. First, though, I'm going to give you a look at what's on the block diagram of this. And then we'll go into more multi-axis controls and methods. So we start out, as I said, we can look at the jog routines are unique in that not only do we look at the functions, I provide for you a full producer-consumer structure, including error handling. This you can use for these programs, or you can use for any of your LabVIEW programs. We start out with initialization function, which sets up the host and opens up the communication with the Trio controller. The next thing we can talk about and is set up for you is the controller setup. This will set up the parameters for you and give you an example as the setup here handles all of the setting of the types, units, accels, decels, limits, as well as enabling the axes.
You'd also mentioned something about faults. Will you be getting into that a little bit later?
I sure will. So any of the programs handles faults. So here's like the jog routine. Each one of these has an error handler. This VI will demonstrate or handle every fault that can occur and give you a communication or data on your error of what it looks like and what is on that axis. Everything from communication to command errors to limits, software, hardware limits, dry faults, and following errors on the servo.
So you've actually got a little troubleshooting guide built right into your interface, it looks like.
Everything is built in.
Great.
So here is a consumer producer or producer consumer. We're going to take a look here as a jog function. We can then write the jog and then open up, as I said, all our high level jog functions available to you. So that's a good example of jogging. So as J.D. was asking, why don't we take a look at some more functions available? So I'm going to open up a demo of a lot of the hardware or a lot of the software functions, including limit handling. So this example demonstrates homing, relative moves, absolute moves, setting positions, as well as writing parameters on multiple axes.
Hey, Eric, if someone is not a motion control expert, are they going to be able to work through this and understand everything that's going on?
Well, everything here is a high level. You don't need to know how to do an ActiveX or any of this. You can go directly from the examples and take a look and see how any of these moves are done, such as let's take a look at a relative move here. We're going to start the program running, and we're going to move back 10 millimeters negative, and we're going to do that again. And as you can see, the error handling has been, we've hit the reverse limit on the axis, and this is handled automatically for you. Now let's take a look at homing. We're going to use one of the home selections here that's pre-written for you. So this is actually running forward, creeping off of the home switch. Let's remove. We can be doing that on multi-axes simultaneously. Once the homing is set, I have a software limit set as well. So again, I have that hard coded to -15, and here it's handling the software limits.
So in these examples, you don't need to code in different parameters or different functions in the homing. You've got everything right here.
The homing is totally designed for you.
It's awesome. It's great.
So let's take a look at what's on the block diagram. Again, very similar to the jogging, we have the set and parameter setup, but here we have a homing function already set up for you. You just choose what kind of homing you are. Here we're reversing at a speed to switch and then creeping forward off. This you need basically to just tell the axis forward speed to the switch and speed off the switch. All that and the hardware input to do it. All of this is automatically included. Other things that we can look at are setting up software limits automatically, relative moves, absolute moves, as well as setting up any of your parameters. So that's a good example of a basic multi-axis.
So we've been talking multi-axis. The name of this video is multi-axis. Let's see some multi-axis motion going on here.
So let's give another example of a ratio.
Oh, perfect.
So what we're going to show here is we're going to show the two axes motion using ratio. So this example now, we're going to take both our axes. Why don't we home them first so we'll get them running together here. Okay, we're home. So what we're going to show here is we take a master axis and a slave axis, and let's say we want to do a ratio of 2, and let's run the master to 50, absolute position of 50 millimeters. Let's take a look here. Okay, that's pretty good. Let's home it again. And we can actually take that and we can change the speed.
So in that last example, your master axis basically just ran 2 times faster.
That is right. So we can then actually take the master and switch them around. Let's take it up and run the axis 1 as our master and axis 2 is our slave.
And we don't got to change cables or do anything here, right? No. Everything's handled via the software?
Everything is in software. And once again, we can home the axes, demonstrate, and change our speed on the fly. So let's take a look at the block diagram again, what we've added here. So here it was actually demonstrating, we have VIs that demonstrate, actually set up the ratio for you. And then in the example here, we demonstrate how to not only link the axes together, but importantly, how to delink them as well. So that's a good example of different multi-axis operations available with the Trio Motion Toolkit.
That's great. So a customer wants to get your toolkit, Eric. How do they go about doing that?
That's a great question, J.D. Here's where you find the Trio Motion Toolkit. Go to any of your LabVIEW programs and under the Tools pull-down, go to Find LabVIEW Add-ons. That'll bring you directly to the Trio Motion Toolkit under the NI Tools network. There, type in Trio, select Trio Motion Toolkit, and you will then be able to load it from the Trio Motion Toolkit screen and purchase it directly from NI. If there are any questions, please contact me or J.D. Teter at PowerMation, or Stephen Leeds at PowerMation, or Ed Novak at Trio Motion Technology.
Thanks everyone for watching video number 3 in our series of the Trio Motion Toolkit for LabVIEW. Join us for video number 4, where Eric is going to take us through some servo tuning using his LabVIEW interface that he created. As always, if you're liking what you see, go ahead. Even if you don't like what you see, hit that subscribe button, because you never know what's going to pop up on this channel. Go ahead and hit that like and subscribe button. Look for more how-to content and maybe a little comic relief from the Power YouTube channel. Thanks. Have a great day.